Your kit comes with a variety of cutting blades for all your needs. The thin, short blades are for precision cutting. The long blades are for cutting thick pieces of foam. The thick router blades can be made into any shape. The close hole is for precision cutting and the far hole is for cutting large pieces of foam. Now you are ready to start cutting. Trace or freehand draw your pattern on the surface of the foam with a water-based ink pen. Use a scrap of foam to make sure the heat setting cuts the foam but does not smoke. You can also pin a template made from poster board if you plan to keep reusing the same pattern. Just follow the pattern that you have drawn. Turn on the power and slide the foam across the blade, keeping the foam pressed lightly against the fence. Here we are using the long blade to cut a block of foam. Even when the cutting wire is guitar string tight, it will move slightly when you try to cut too fast. This can be minimized with the blade stabilizer. The tool cord must stay connected to the lower blade connector under the table and to the upper horizontal post to avoid shorting out the power station. Wrap the cutting wire once around the lower post before mounting the cutting wire to the upper post. Making angled cuts is just as easy as making straight cuts. With the traveling fence, you can make complex angle shapes even when your foam pieces do not have a straight edge parallel to the edge to be cut. A piece of foam can be placed onto the guide at any angle. The larger traveling fence is for larger pieces of foam. A simple method for making a complex cut is to match the edge of the geometric pattern drawn on the bottom of the foam to the edge of the fence. The smaller of the two traveling fences is for smaller pieces of foam. With the 3D table, making cylinders and cones is fun and easy. The cutting blade will be at right angles to the table for making a cylinder. Turn the power back on and spin the foam on the center pin. Remove the outside layer of foam. To make tall, skinny cylinders, you may need to support the top of the foam with the pointed screw on the other post. Making cones is just like making cylinders, except you will adjust the blade to the required angle. It's good practice to stop just short of the final cut. And remove the outside foam before making your final cut. A traditional lathe pulverizes the outside layers. The 3D table will only leave one thin cut in the outer layer where the blade enters and exits, leaving you with a usable negative of your cylinder or cone. We didn't complete the turn here, but this is easily fixed by simply finishing the turn. Did you think that making perfect cylinders and cones could be this easy? Leave the post clamp loose so it can be adjusted up or down and in or out while bending the router blade into the desired shape. Now tighten the post clamp. Position the foam, then slide the stationary fence up against the foam and clamp it in place. You are now ready to turn on the power and make shaped cuts. You can also try the supplied ribbon blade for making molding. With the 3D lathe, you can make wide and narrow cylinders with contours in them. The 3D lathe setup is similar to cones and cylinders, except you will use a router blade instead of a long or precision blade. Slide the foam into the cutting blade and lock the traveling fence in place with the U-clamp, or just hold it in place by pressing down on the center. If it's a tall piece of foam, pull the horizontal arm that has no blade to position above the center of the top of the foam and lightly screw the spindle into the foam, just like we did with the tall cylinder. You will produce some cool shapes while in the process of learning, so be patient and enjoy the creative process as it unfolds. Even when the cutting wire is guitar string tight, it will move slightly when you try to cut too fast. This can be minimized with the blade stabilizer. Wrap the cutting wire once around the lower post before mounting the cutting wire to the upper post. The tool cord must stay connected to the lower blade connector under the table and to the upper horizontal post to avoid shorting out the power station. The 3D table can be easily configured as an overhead milling machine. Move the tool cord connector from under the table and clip it onto the horizontal post that normally has no power connector. The tool cord should also be connected to the other horizontal post. Shape the router blade down below the two horizontal posts. The router blade will quickly and efficiently mill the top surface of the foam. Plunge cutting requires the hot knife and sled guide, which are not part of the standard 3D kit. Clip the hot knife into the holding clip on the sled guide. The hot knife should pass through the hole where the cutting wire would normally pass through the table. Mount the sled guide and hot knife upside down on the bottom of the 3D table with the supplied screw and wing nut. Move the entire 3D table so the front end overhangs your work table by 8 inches. As you can see, this is a fast, efficient technique to quickly make holes and cutouts. The 6 and 8-inch Pro knives can be used to plunge cut large blocks of foam. Overhead engraving requires the long engraving tool, which is not part of the standard 3D kit. Position the holes in the two horizontal posts directly over each other. Drop the engraver blade down through the holes and set it to the desired engraving depth. Tighten the post clamps. This setup allows you to make controlled same depth engravings on the surface of a flat piece of foam. With the gravity table set up, long accurate cuts can be automated. The foam will slide through the wire like magic. The 3D table is the ultimate multi-use pro modeling machine. Built for professional modelers, our combination scroll table, router, lathe, and milling machine comes in one versatile tool kit.